doing another video on roots of complex numbers. Guys, thank you very much for you being here, and thank you guys for following the lecture series. I hope this lecture series is helping you to become better in terms of applying your mathematical knowledge and stuff. So today we're doing another video hoping to explain the concepts behind roots of complex numbers. So you have a question there. You say find 4 zeros. Now zeros is just another way for saying roots. Okay, find the 4 roots of the polynomial, one of them being that. Okay, so let us go there and find the roots. Okay, so the solution here is that first thing first that I do in all the videos that you are looking at, that you are watching, was that I look at the 2, n minus 1 is equals to 3. If n is 4, n minus 1 is equals to 3. Okay, that's the first thing I'll do. Other thing I'll do with this one is that I'll understand that if I want a 0 of this has to be true. If I want the 0 of that, so z to the 4 will be equals to negative 4. Now this becomes an interesting fact. Okay, so this becomes our complex number. Let us look at the modulus of our complex number. So our modulus of the complex number is going to be this, which is just 4. Okay, modulus of this complex number is just 4. It's too easy, it's too easy. Let's see. So since it only has the positive, the real part, which means we're only going to consider this cos of theta is -1, where our theta is pi. Guys, I know we have done this multiple times, where our theta lies between negative pi and pi. So then it is true, we can use it. Okay, so let us write this complex number in exponential form. It's going to be this. It's going to be 4 e to the I, then we're going to have that plus 2 pi k, where our k is equals to 0 plus minus 1 plus minus 2 da 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 da. Okay, now let us find the general equation of the root of the complex numbers. So ck is equals to the 4th root of our modulus, and then have e to the I, then we have pi plus 2k pi divided by 4. Okay, where our k is equals to, well, I don't need to write this as yet. Okay, I can just simply do that, and this can be written as the square root of 2 and have ei pi plus 2 pi k divided by 4. Okay, so this is our ck. Wow. This is our ck, guys. So as I like to modify this, I can rewrite this whole term that we have here as pi over 4 plus k pi over 2. That's how I'm gonna denote it from now. Okay, that's how I love to denote it. So let us find c0, which is our first root, the first 0, the first root. Remember, guys, as I said, zeros are roots, roots are zeros. Okay, so let's find c0. c0 is the square root of 2. This is just 0. Okay, so it's going to be e to the I pi over 4, which is just the square root of 2 cos of pi over 4 plus I sine pi over 4. Okay, so this will be equals to square root of 2. Now, since pi over 4 is a special angle, I was going to ask you guys what is this. So yeah, now this will be equals to, we multiply each and every term by that, so it's going to be 1 plus I. So this is one of the roots, and if you can remember well, we were given this because they said one of them being this, so this is confirmed by this, what we have here. So let us find the other 3 one. So C1 is equals to the square root of 2 e to the I. Now guys, as I said in the last video, I won't show you how to do the D. I will just continue with that. So the angle that I find here, because remember that if k is equals to 1 here, so it's going to be pi over 4 plus pi over 2, and pi over 4 plus pi over 2 is always 3 pi over 4. So I'll just write it here, 3 pi over 4. So this will be the square root of 2 cos of 3 pi over 4 plus I sine of 3 pi over 4. Okay, now it's a special angle, guys. It's a special angle. It doesn't change. Okay, it's just that it affects certain parts. Like this one, it will be written like this, plus I 1 of root of 2. Okay, now I multiply each and every term by the root of 2, becomes minus 1 plus I. Okay, now let us find C2. So C2 is when k is equals to 2. So we're going to have the square root of 2 ei, guys, 2, it's going to be pi, so it's going to be 5 pi over 4. Now remember the pattern that I was showing you in the first example that we ever did. We are seeing it again, pi over 4, 3 pi over 4, 5 pi over 4. What's going to be the next one? Please comment down below. Okay, so this is going to be the square root of 2 cos of 5 pi over 4 plus I sine 5 pi over 4. So in this case, both sine and cos, or in this angle, both sine and cos are negative. Okay, so square root of 2 negative 1 square root of 2 minus I 1 square root of 2. Okay guys, so this will be just minus 1 minus I. Okay, so the last one, C3. Now as I said, guys, we're seeing the same thing, so it's going to be ei 7 pi over 4. Okay, you see the increase has been with respect to 2. Okay, that's been with respect to 2. So can I have the square root of 2 cos of 7 pi over 4 plus I sine 7 pi over 4. Okay, so this will be the square root of 2. Now in the 7 pi over 4 part, only sign is negative there because it lies in the 4th quadrant. So it's going to be 1 over root 2 minus I 1 over root of 2. Okay, so this will be just 1 minus I. So these are all the 4 what do you call this, zeros that we need to find. The first 0 is this one, which was given to us. Second one is this one, third one is this one, and the 4th one is this one. This example and the first example, they've got very similar, very similar ideologies in terms of the interchanging of I and I mean the real part and imaginary part, real imaginary, because both real and imaginary are positive. Real is negative, both are negative, and the imaginary part is negative. If you came this far, guys, please hit that like button, please subscribe, guys, please share the videos. Thank you very much for coming with me this far.